To support our discussions with the world's leading thinkers, please see the video description or visit eism.eu/support. Thank you.
Hello and welcome to A Theory of Everything. Today we have the privilege of talking to Professor Hugh Price, a highly influential philosopher and proponent of retrocausality, which is the idea that the present is caused not only by the past, but also in some sense by the future. Professor Price is the Emeritus Bertrand Russell Professor of Philosophy at Trinity College, Cambridge. As you know, Cambridge is one of the oldest and most prestigious universities in the world. For over 800 years, it's been at the forefront of intellectual inquiry and innovation, contributing in far-reaching ways to our understanding of the world through the work of people like Isaac Newton, Charles Darwin, Stephen Hawking, and many others. I say this because it's here at Cambridge that Professor Price co-founded the Center for the Study of Existential Risk, or CSER for short, along with Sir Martin Rees, the renowned astrophysicist, and Jaan, a venture capitalist and founder of Skype. In addition, Professor Price served as academic director of the Leverhulme Center for the Future of Intelligence, also at Cambridge University. This combination of work on existential risk, the future of intelligence, and retrocausal physics is an especially relevant research agenda that aligns well with the technology we're developing at ASIM in collaboration with a team of top researchers from around the world. The intellectual glue that brings these various concepts together is Professor Price's interest in decision theory. Here, his goal-oriented pragmatism aligns well with our proposal to use social choice theory as the ultimate tiebreaker in science. In other words, if you have two equivalent mathematical formalisms or models of reality, both of which are consistent with experiment, but one of them leads to practical advances in decision theory while the other is silent, then the picture that leads to greater knowledge of how decisions work is preferable. This is common sense, and of course, Professor Price agrees. As you might imagine, it was impossible to do anything like justice to the full range of Professor Price's work, so I encourage you to check out his books and articles. I will leave a list of relevant links in the video description. Thanks again for your time, and thanks to Professor Price for sharing his important work with us. So, Professor Price, I'd like to accomplish three things today. One is celebrate your distinguished career and your intellectual accomplishments, drawing special attention to your work at the Center for the Study of Existential Risk. As I mentioned, your work there dovetails nicely with our mission and our central research question here, which is how can the human species keep from destroying itself, or at least from large-scale calamity. The second thing I'd like to do is to make a huge jump, or an apparently huge jump, from there to your important work on physics, on the physics of time and retrocausality, or the idea that the future has something like a causal impact on the present. And lastly, I'd like to bring these apparently disparate aspects of your career, your work on existential risk and your work on retrocausality, into kind of like a single overarching conceptual or research framework. So on the surface, one would think that these two things are unrelated, but I'm going to make an empirically based argument that they are actually quite connected. And so to accomplish this, I think your work on decision theory and our work on social choice theory is going to come together nicely, at least maybe so. Of course, you're welcome to disagree. So can we begin there with your work at the Center for the Study of Existential Risk? Please tell us about the center and what it does and your activity there.
Thank you, Louis. And I should say at the beginning, please call me Hugh, not Professor Price. You'll make me nervous if you're too formal.
Okay, perfect.
Coming back to Caesar, C-S-E-R, Caesar as we all called it, and the name was, of course, a small academic joke. One of our early postdocs actually was a person whose first name was Julius, and when we asked him at his interview why he wanted to work for Caesar, he said he wanted the email julius@caesar.org. Caesar came about. You mentioned Martin Rees, who with me was one of the 3 people who founded Caesar, but the third, who was equally important, was a man called Jaan Tallinn, who was, when I met him, he was sort of had achieved prominence as one of the inventors of Skype, which of course was even more important back then in 2011 than it is now, because we didn't have competitors like the one that we're using now. So being one of the inventors of Skype was a big thing. And when I met him by accident at a conference in 2011, when I was on my way to Cambridge, I discovered, I happened to share a taxi with him, that the thing he spent most of his time on in those days was trying to get people to think more about what he saw as the potential dangers of AI. And I found that very interesting. I sort of heard about some of those ideas in theory, but hadn't met anyone who took them seriously, especially not somebody with such a good background in the computer industry. And in Cambridge, I already knew Martin Rees, a very distinguished astronomer whom I met through philosophy of cosmology circles. He was at that point still master of Trinity College, where, as he said, I was going to take up a fellowship. And I knew that he'd written about the human future, the long-term future, and technological risk and things of that kind. So it occurred to me that there was a project here. Perhaps I could introduce these 2 very interesting people, distinguished in very different ways, but interested in similar things. Perhaps I could introduce them to each other, and maybe we could make something happen in this area in Cambridge. And so that's how Caesar came about. I mean, it took a couple of years to make it happen, but I found a way to bring Jaan to Cambridge and introduce him to Martin and so on, and we took it from there. So that's how I became involved in a center which was attempting to study existential risk and do something about them. And it didn't really come from my own intellectual background so much as from the fact that I'm one of those people who sort of enjoys helping to make things happen. And I was just on my way to Cambridge from Sydney. In Sydney, I've been involved in setting up the centre you mentioned, the Centre for Time. One of the things I had in my mind when I was moving to Cambridge was that it would be good to find other projects there, in particular projects which sort of reached outside philosophy in some way, as the Centre for Time did in Sydney, because it involved working with quite a lot of physicists and psychologists and other people like that. So when I met Jaan and realized that there was a potential link with Martin, I thought, well, perhaps this was the project I'd been looking for. And it turned out to be a very engrossing project and a very worthwhile one, and one that led to other things, such as the other centre you mentioned, the Leverhulme Centre for the Future of Intelligence. And I don't know whether this conflicts with the direction you're hoping to take the conversation. As I say, I think it relates much more to the pleasure I get from being what I sometimes call an enabler, somebody who likes helping to make things happen within the academic space, and not from my own intellectual interest so much.
Well, interesting. No, I don't think it conflicts at all. In fact, one of the reasons I reached out to you, and I think one of the reasons that this exchange could be especially interesting or valuable for, at least for us, is the fact that this apparent leap maybe that took place maybe by chance. It seems like it wasn't so much by chance, in the sense that there's an interesting connection between your work in philosophy and philosophy of physics concretely, and the study of existential risk. So we'll get into that a little bit later, but let me ask you first, does it feel like these are two completely separate activities or aspects of your career and your thinking?
Yes, I mean, sort of in serious terms, yes. I mean, there've been some minor connections which we could talk about. One of them, for example, was in decision theory. You mentioned that I'm interested in the philosophy of decision theory. One of the topics that I've been interested in is whether a deliberating agent can meaningfully predict their own behavior or their own action while they're in the course of making up their mind what to do. I mean, there's a philosophical debate within the philosophy of decision theory about that. And I discovered at some point, probably around 2014, after CSER had been up and running for a year or two, that was closely linked to an issue that some of the people thinking about safety issues in artificial intelligence at that time were thinking about. So that was a surprising small technical connection that came out of the blue. And when I mentioned to Jaan one of the times he was in Cambridge that I'd discovered this connection, which I didn't know anything about at the beginning, and he said, "Oh, it's the pull of the future."
Exactly.
It was 75% a joke, of course, but there is the thought, which was sometimes in our mind, that the future steers us towards particular interests and activities.
Sure. Well, I understand how that could be taken as a joke and taken lightly from a scientific perspective, definitely. But in terms of just conceptually and scientifically, connecting the idea of time and decision seems like a worthy object of study, because time necessarily enters into our subjective experience of decisions.
Yes.
Would you not agree with that?
Oh, yes, absolutely. I mean, where it's harder to find a connection is between the interest in decision theory and time on the one hand, and existential risk on the other.
I see. Okay.
But just focusing on time and decision theory, yes, absolutely. I mean, one of my big interests over, really decades now, has been trying to flesh out the way in which our perspective as agents, creatures who act so as to intervene in the world, how that's reflected in many of the temporal and related concepts in terms of which we describe the world, including in particular our causal concepts, and also our sense of the directedness of time. So there are very close connections between my interest in decision theory and some of those philosophical issues about time and causation.
Okay, excellent. Well, at the end, if it's okay, we'll talk about what we're doing at ASEM to connect those two. I was imagining that you didn't see the connection between, wrongly imagining that you didn't see the connection between your work on time and decision theory, but the connection is pretty clear and obvious, no? Okay, fantastic. And so a little bit later, we'll try to connect the existential risk to decision theory and your work on time. I think there's some interesting potential connections, and many leading researchers and thinkers agree with us, and they're on board, and we're actually part of a larger research program or agenda. So I think you'll find that interesting. Can you tell us about to delve a little bit deeper into decision theory and time? Tell us about how they're how they're connected, and maybe you can elaborate on your own philosophizing and theories about time and, for example, the equation E equals CCC.
Okay, well, it'll take us a bit of time to get into that reason stuff, but I could say something first about, as it were, the connection between decision theory and time and causation. So, sort of coming at it from the direction of the philosophy of causation, you could say there are two or three big puzzles about causation. One is, well, what's the difference between cause and effect? Another is, why does that causal arrow, the arrow from cause and effect, from cause to effect, why does that always or almost always seem to line up with the temporal arrow? So why is it always or almost always the case that the cause is in the past and the effect is in the future? Perhaps the third issue is, what's the relationship between cause and effect on the one hand and practical decision, means-end reasoning on the other? I mean, it's pretty clear that cause-effect is useful to us if we're engaged in means-end reasoning, because roughly speaking, we can bring about the causes in order to achieve the effects as ends. So the causes are the means and the effects are the ends. What's the nature of that connection? And depending on your view of causation, you have to give different sorts of answers to that question. I mean, if you think of causation as some, entirely objective relationship of some kind in the physical world independently of us, then you have to explain why it's connected to means-end reasoning in the way that it is. Or is that connection universal, or are there some cases where we could, as it were, be involved in means-end reasoning which didn't track that objective cause-effect relation that you think exists in the world? So there are questions of those kinds, making sense of those three aspects of causation: the difference between cause and effect, the temporal orientation, and the connection to means-end reasoning. And I think the best answer to all three of them is if we start in the middle with our own perspective as agency, as agents, and then see the description of the world in terms of cause and effect as being a kind of objectification of the distinction we need to draw between means and ends, ways of achieving things and what we achieve. So by starting, as it were, in a subjective place like that, you end up with having, in my view, the best answer to all three questions. So roughly speaking, the difference between cause and effect is the difference between a means and an end. The temporal arrow comes from the fact that we ourselves and all the agents we know of in our region of the universe have a built-in temporal orientation from past to future. And the connection with decision is immediate because you just built that in at the beginning. So in my view, what I these days would call a neo-pragmatist or an expressivist account of causation, some people would call it a subjectivist account, gives by far the best answer to the three biggest problems in philosophy of causation. Okay, is that enough to explain why I think that there's such a tight connection between issues of causality and issues of decision and agency?
Yes, of course, that's great, and it would be nice to connect that to your work on retrocausality. How do you fit that into this picture?
Okay, let me just mention one other thing that may be helpful to some of your listeners. One other analogy. Among philosophers talking about probability, there's a very common and widely held subjectivist view, namely that to understand probability, we have to start with the fact that we're all our lives we are in a sense betting, as the great Frank Ramsey put it. So in effect, we're always having to make decisions under uncertainty. In those circumstances, it's very helpful to sort of codify and objectify our degrees of uncertainty. And that's where talk of probability comes from. It comes from that practical or subjective or pragmatic place. My view of causation is the same kind of thing. Okay, that was an analogy to help people understand the view about causation. Now to retrocausality. The view of causality that I just sketched is a view according to which, in effect, what we're doing when we're discovering causes in the world, or cause-effect relations in the world, is, in effect, going around the world, wiggling things, changing things, and seeing what else changes when we do that. So, in effect, we're investigating potential means-end relations all the time. That's very closely related to what's become a very influential view of causation, which is called the interventionist approach, developed perhaps in a slightly less pragmatic way than I do, but by Jim Woodward, for example, as well as the computer scientist Judea Pearl. Okay, so if that's how you think of causality in terms of this, this empirical business of going around the world wiggling things and looking to see what other things wiggle as a result, then it's a question, why is it almost always the case that the other things that wiggle are in the future, they're later than our initial wiggles? And is it always the case, or could there be exceptions? Now, I already talked about the answer to the first part of that question. In effect, the ordinary fact that effects come later than their causes is because when we're thinking of wiggling something, we're always putting ourselves into the picture just before the wiggle. So any opportunity for a downstream wiggle can only be in the future of our first wiggle, because we are ourselves in the past. So that's where the ordinary direction comes from. We could talk through an example if you want to go into that in more detail. But what that leaves open is the possibility that the structures in the world might be such that in some cases, if we wiggle something in the future, then in virtue of connections between that and in virtue of the laws of nature, that might have the effect of changing something in the past, of wiggling something in the past. So it turns out that this interventionist approach to causation doesn't absolutely exclude the possibility of retrocausality, although it does explain why the great majority of causation is forwards causation. And retrocausality would have to be something a little bit indirect. It would have to involve a kind of indirect wiggle. So we wiggle something else changes in the future, and then changing that changes something in the past. So retrocausality has to involve a kind of zigzag structure. Now, the reason that's interesting is, as you know, and I know that you've talked to some of the quantum physicists who do great work on these ideas, is that it looks like that possibility is a very useful one in quantum mechanics. And that's an idea I've been interested in for a very long time, almost 50 years now. From 1976-77, for 1 year, I was a master's student in Oxford, doing a master's in mathematics. And there are a lot of interesting workshops and conferences of people interested in what these days we'd call philosophy and foundations of physics. And at one of those, I went to a talk, which I think was probably the first talk I ever heard about Bell's theorem. And somebody was giving an exposition of Bell's theorem. And they said, as is quite quite standard. Of course, we assume that the particles don't know what measurements are going to be performed on them in the future. And I thought, well, why are we entitled to assume that? I mean, I'd already done enough philosophy of time to have the view that, basically at the underlying level, it was all symmetric. It was a block universe picture. The ordinary asymmetry was sort of macroscopic statistical stuff. I couldn't see why we were entitled simply to assume that at the microscopic level, particles couldn't know about what's going to happen to them in the future as well as about what had happened to them in the past. And it seemed that the assumptions seemed to be playing such a crucial role in this result that everybody clearly thought was important. I thought, why is that assumption made? And is there an option of relaxing it? And slowly over the years, I kept coming back to that question, and I found a few other people who thought the same way. And my own ideas about it sort of improved. And I still think it's an extremely good question. And it's the obvious way of reconciling Bell's extraordinary work with relativity. Because Bell showed that in effect, when we have one of these EPR Bell experiments, put two particles sent in opposite directions, they can be at space-like separations from one another. What Bell's work shows, in effect, is that there can be correlations between the measurement choices and the outcomes in the two experiments, which can't be explained in terms of some common cause picture, some pre-existing properties that the particles had when they separated. And that seems to suggest, by what philosophers call the principle of the common cause, that the only other option is that somehow the experiments at one side are having a subtle effect on the results of the experiment at the other side. Very subtle because it can't be used for signaling, but Bell's theorem seemed to imply that there was some subtle effect. And that seemed to conflict with relativity because it seemed to mean that we need a sort of preferred frame in which this effect was instantaneous. But already before Bell's work, back in the 50s, just responding to the so-called Einstein-Podolsky-Rosen argument, it had been proposed that particles in those sorts of situations could be connected by a zigzag path through the past. And so, in effect, a measurement on one particle would affect the history of that particle back to the time when the particles separated, and then by forward causation on the other particle world time, you can have a connection between the two separated particles in a way which looked thoroughly compatible with special relativity because it all stayed within the light cones. So there was what seemed to me to be a sort of obvious way of trying to make Bell's results compatible with special relativity, and it puzzled me and still puzzles me why it's taken people so long to explore this idea. The view is better known these days than it was 40 or 50 years ago, even better known than it was 15 years ago. And some of the people are some of the people who deserve credit for that. But still, it's still a minority position. Okay, so that's my interest in retrocausality. First, and it's a combination of two things. One is the interventionist approach to causality. Although it maintains that the ordinary direction of causality sort of comes from our own orientation as agents, it clearly leaves open the possibility that there might be retrocausal structures. And then the argument from quantum theory and from Bell's theorem provides, in my view, a very strong reason for taking that possibility seriously.
Excellent. Well, you are not the only person who, as you mentioned, who thinks there are interesting possibilities for the concept of retrocausality. However, as you also mentioned, it's a minority view. Sometimes when we discuss or bring the topic up with other researchers or scientists, the immediate reaction is one of skepticism, rightful skepticism, or maybe outright balking at the idea. Can you mention some of the thinkers who have been aligned with retrocausal concepts? I think there's a couple of Nobel Prize winners, of course, Yakir Aharonov and his team. In your eyes, who are some of the most important thinkers along this line?
Okay, well, so one thinker, if we just want to stick to Nobel laureates, one thinker who was influential on me because I found the idea floated in an obscure paper by him in the late 70s was Tony Leggett, who later went on to win a Nobel Prize. Now, he's never developed the idea, but I know from recent correspondence with him that he's still quite sympathetic to it. Another Nobel laureate who has views which, as I was able to check indirectly with him recently, belong in the same camp is Roger Penrose. I was recently in a visiting position in Bonn, and one of the philosophers of physics there is in regular contact with Penrose in the context of a project on the history of gravitation. And so he checked with me. He asked Penrose whether I was correct in labeling him as a retrocausalist. And he reported that Penrose said, well, I don't use the term myself, but basically yes. So there's somebody else who takes the idea seriously.
Yeah, I think there's the comment about Penrose, who said, I can now talk about these things because I think I forgot the word he used, maybe well established or something to the effect.
Oh yes. This is a story that I got from Penrose's collaborator on the science of consciousness is a person called Stuart Hameroff in Arizona, I think. And Stuart told me that there was a story about Penrose from the 1990s at some sort of workshop or conference about Bell's theorem, quantum foundations at the Royal Society in London. And Penrose was drawing these zigzag diagrams, space-time diagrams on blackboards or whiteboards, the kind of, in effect, showing the kind of zigzag causality I talked about a few minutes ago. And according to Hameroff, Penrose then said, I can get away with talking about this kind of stuff because I'm already a fellow here.
Exactly.
Yeah.
I think it strikes me that there's an element of this reluctance to be an outright proponent because it's associated with crack pottery, if you will. Is that a sensation that you also get, or is this in the general public, among scientists, much less so, of course, but in the general public, is that something that you sometimes perceive?
Well, I mean, people maybe perceive me as a crackpot for various reasons, but I don't think retrocausality is high on the list. There are other things, but the person I mentioned, I didn't name him, but the person who in the 50s, before Bell's work, wrote about these ideas of zigzag causality in the context of EPR experiments was a French physicist called Olivier Costa de Beauregard, who had been a student of Louis de Broglie in the late 40s and had come up with that idea then. Now, he certainly was interested in possible links between retrocausality and ideas like precognition and so on. And, I don't know, possibly telepathy. And so I think there were associations there which may have made it harder for him to get his ideas taken seriously at the time, given what a conservative bunch many physicists and philosophers as well are. No, I've never sort of explored that possible connection myself. I don't rule it out completely, but it always seemed to me somewhat unlikely, partly because it would require that these tiny quantum effects have have implications at the level of the brain. But of course, Penrose and Hameroff believe that anyway, so it looks like a much more attractive idea from their point of view. I should say, though, that my views about this have shifted a bit in the last year or so. You mentioned this the hypothesis that E equals CCC, as we put it. In other words, that entanglement is what my collaborator Ken Wharton and I call connection across a constrained collider. Now, that's an approach in which the appeal to retrocausality is really very much more subtle, and I think it's the approach is interesting partly for that reason. So, if you'd like to talk about those sorts of ideas, we could talk about that.
Well, we're running out of time here, so I would love to talk to you about that. I had originally planned to talk about that. However, I'd like to also talk about, well, briefly, one comment. Retrocausality in the 50s when Costa de Beauregard was talking and theorizing about it, was a completely different scenario than it is today. And I think a big part of the reason is your work, also the work of people like John Kramer and Yakir Aharonov, but in particular Yakir Aharonov, because his research program and his team have come up with so many empirical fruits to the approach. What's your take on some of the advances that he and his team have been able to make from these highly philosophical, theoretical concepts and ideas to actually practical, laboratory results?
Well, some of it is too technical for me to comment on with any sense of expertise. As I'm sure is obvious from what you know of my work, I'm a philosopher, not a physicist. And I've several times I've been in meetings where some of that group have put forward their ideas, and then there've been other people in the meeting who say, but all of that can be explained in terms of conventional quantum theory. Now, I'm not I don't have sufficient expertise to adjudicate on that question. And so there's nowhere where I feel in a position to, as it were, put my finger on one of their results and say, yes, this is a really strong argument for retrocausality. So I have to stick with the kind of arguments I know, which are the arguments to do with the potential that this has for explaining Bell correlations.
I see. Okay. Well, you're right that people sometimes object that the findings and the progress that Aharonov and his team, we collaborate very closely with both Eliyahu Cohen, who serves kind of like a principal investigator with us, and Avshalom Elitsur, that a common or recurring objection is, this is not necessary to think about retrocausality, because you can explain what happens with the traditional approach, the one-wave function approach. And I think the response is equally, that's of course a logical response. But I think the response to this response is even more compelling from my humble perspective, because if a certain model of nature or a model of reality helps you make progress, and that progress was not evident through another model, then it's not fair to say, no, I could have reached there with the other model. Yeah, but you didn't. You didn't reach it.
Yeah,
So
no,
right?
that's a good argument. But I don't know the details well enough to sort of express an opinion about any particular instance of that kind of argument. But I agree with you that it's a good argument. One other thing I should say is that there's one respect in which my kind of gut instincts about what retrocausality would lead to is in tension with the model from the group around Aronoff. And that's that, as I understand it, that's a model in which you take the wave function very seriously, as it were, the fundamental ontology, as philosophers say. In fact, you take it even more seriously than usual, in that there are two of them rather than only one. It always seemed to me that the promise of the retrocausal approach was that it would remove the obstacles to a hidden variable approach in which the wave function is treated as a kind of description of our knowledge, or something of that kind. Now, that doesn't mean that there isn't a role for a second wave function, because you can, as it were, describe the knowledge we would have if we knew the stuff in the future, not the stuff in the past. But I think it is in some sort of tension with the way that group tend to understand the physical significance of their model. And perhaps an extreme example of that is Lev Vaidman, somebody I've met many times at conferences. And Lev is, of course, describes himself as a proponent of a many worlds view, whereas to me it's always seemed that retrocausality was a way of avoiding that sort of stuff. I mean, because one of the big advantage of an epistemic view of the wave function is that collapse is just something like a state change in the state of our knowledge. So the measurement problem looks a lot more tractable, and so the case for the many worlds view looks a lot weaker.
Well, Lev's position has always surprised me, precisely because it's the many worlds. It's untestable. It's hard to understand how he takes the same evidence and the same work that Aronoff has done. Of course, they collaborate closely, but come to opposite conclusions. And that brings me to in some sense, the final stretch of our discussion today. And that's about different models of reality. Like in this case, Lev Vaidman and Yakir Aronoff take the same exact study of nature and come to opposite conclusions. Similarly, across all branches of science, we all seem to take our same experience with nature, and we come up with different models, right? And this happens across all the sciences, and physics, of course, is no exception. In fact, it's a prime example of how different models of reality tell different stories about what nature is like. Our approach at ASIM regarding the connecting your ideas and your work in these two apparently disparate realms, existential risk on the one hand and philosophy and physics of time on the other, is the idea that if a model, any given model about the world, using any language at all, allows us empirically to make real progress in some of the biggest open questions, excuse me, in either decision theory or social choice theory, political theory, then that particular model has more value, more immediate practical value, and this is aligned with your pragmatist approach, than a model that's not able to make those connections. Does that seem like a reasonable position or argument to take?
Yes, I find that kind of pragmatism in philosophy of science quite appealing. As it's usually applied, it would look for progress within the sort of field of problems defined by, roughly speaking, the scientific field in question. Now, if I understand it, you want to apply it in a rather broader way, in that you want to draw links between sort of particular models within quantum theory and, if I've got this right, the broader issues about existential risk and things of that kind. And if that's right, then I think you'd be sort of taking we should believe something if it works, pragmatist point, and sort of extending it outside what even pragmatist philosophers of science would see as its normal domain of application. Now, I'm not saying that that's not an objection, but it's a kind of, it's sort of cautionary flag.
It's an observation.
I think if you do want to argue that way, then the argument needs to be quite convincing.
I see. Yeah. Well, we've assembled a team of cross-disciplinary team that covers from Eliyahu Cohen and Avshalom Elitzer at the quantum level, and it takes all the way up through chemistry, biology, neuroscience, psychology, and the social sciences, and concretely recent advances in social choice theory, very practical, concrete advances in social choice theory. And so we have representatives from all these branches, and we're coming together, and they're all convinced enough to participate in the program. And I would say, in response to that observation, that yes, of course, we're going outside of any one particular scientific domain. However, given your work at the Center for the Study of Existential Risk, it seems to me reasonable to say, okay, our ultimate goal is to not destroy ourselves. So that's our ultimate goal, right? Across all the sciences. Why? Because if we destroy ourselves, then no science will matter, right? So that's our response to that, and we issue a respectful challenge to anybody objecting to what we have in mind. Okay, this is what we have in mind. If you have something better, then we're all ears, because our goal is not to be right. Our goal is to make actual progress. And I think that's what we're doing. We have one member of the team, kind of extended member of the extended research team, who was Michael Levin, who's at the University of Tufts and at Harvard. He's doing some incredible work, and he is unabashed about his declarations, assertions that his approach is fundamentally goal-oriented. And if it's goal-oriented, there's necessarily some conceptual affinity with the concept of retrocausality. Similarly, across all the disciplines, we're finding people who are making actual scientific progress by taking a goal-oriented retrocausal approach. And so, and like Michael Levin invites his detractors, listen, this is what I'm doing. If you don't like talking about goals, show me something better. Teach me something better. And he's doing some incredible work, and he's slated to possibly be a Nobel laureate for his work. So in our approach to decision theory is precisely this. It's a practical empirical approach. We have one person who's made some really interesting connections between quantum theory and Arrow's impossibility theorem, which is like the central open question in this social choice theory. And so what we propose to do is to, with Eliyahu Cohen as the lead, is to actually experimentally test those ideas and then create, I think you'll find some interesting aspects of this, create an agent-based platform, right? Using the latest technology, using, for example, large language models and partially observable Markov decision processes to simulate agents and then create on computer two states. One, a state where we would like society in an ideal state, right? That's the end state. And then we begin with the starting state is society as it is now. Okay, so then we ask the computer to tell us, how do we get from where we are now to that ideal state? What kind of weights or what kind of voting do we give to each individual person, or what kind of proposed voting mechanisms would most likely get us there? So this is a very practical approach, and that's why we think that ultimately our decisions about some of the biggest risks that we're facing as a species are ultimately that. It's decisions or reconciling different models of reality. And that boils down to voting theory and social choice theory. So that's what we're trying to do. And we think that it's not an accident that you've been able to get into this study of existential risk and then the physics of time. We think there's an interesting potential empirical connection there.
Okay. Oh, that all sounds very interesting. And good luck with that. I certainly agree that these issues as to how we achieve beneficial social equilibria are very important.
Well, thank you very much for your time today, Hugh. As a last question, I know that you have retired from your position at Cambridge. Tell us a little bit about what you're doing now with your time.
For the last 2 years, I've had a 25% position in Bonn in Germany, and so in the northern summer of both of those years, I spent 3 months in Bonn, which was quite delightful. But basically, the life of a retired academic, especially an academic like a philosopher who doesn't require huge resources in terms of laboratory or something like that, is, at least in my experience, a very pleasant one. I have quite a lot of time to get on with my own work. I have writing projects that span most of the things that I've been interested in over my long career. And some of them at least seem to be leading in fascinating new directions, including the stuff we didn't really talk about collider bias and connection across constrained colliders in quantum theory. So at this stage, the life I have is a pretty good one.
Well, excellent. That's fantastic. That's great news. Yeah, we didn't get a chance to talk about some of your latest writing in your papers and the connection across constrained colliders, which I think is interesting ideas, and I think very much aligned with what we're trying to do. We'd love to have you back at some point if you're interested. We'd love to hear more about what you're doing and your work. But for the moment, thanks again for your time today. Appreciate it for you.
It's a pleasure.